So welcome back. We'll be doing question number 10 to 12 in this video. Okay, so the question that is given to us is we're asked to find the area of the shaded region. Okay, so we're asked to find this particular area, right? So in order to find out this particular area, we actually need to know the area of this triangle, but they have already given us the area. They have given the area as, and it's an equivalent triangle. Now since this is an equivalent triangle, all of these angles are going to be 60 degree, right? These are all going to be 60 degree. Clear? So the area of this triangle is given as 17,320.5 centimeters square. With each vertex of the triangle as center is 0. With radius C, what is given? A circle is drawn with radius equal to half the length of the side of the triangle. Clear? But we do not know the side of the triangle. Okay. Therefore, what is given to us? We're given the area of an equilateral triangle. Okay. Equivalent. Okay. It's given as equivalent, but it is actually a typing error that I made. Is equilateral triangle. Okay. So of an equilateral triangle. So this is given as 17,320.5 centimeters square. Now the area of an equilateral triangle is 3 by 4 a square, right? Side square. So that is 17,320.5 centimeters square. Now you take a square to this side. They have given that we have to take root 3. So root 3, when it goes to the right hand side, it will go down, okay, and 4 will come up. But what is interesting is they have given root 3 to be, okay, they have given root 3 as equivalent to how much? Root 3 is equivalent to 1.73205. Clear? So in the next step, what we'll do is we have 1.73205. So since I took out the point to the denominator, this will go, and we're left with 1.73205. Since I have taken out the decimal point, so in the numerator, after the decimal point, you see after the decimal point, how many numbers are there? 1, 2, 3, 4, 5. So 5 zeros will be placed on the numerator. 1, 2, 3, 4, 5 into 4. Okay, so you cancel this, you cancel this, cancel the 0 and 0. This is going to be a square. So 4 into this is going to be 4,000, 40,000. Okay, yeah. And this is going to be a square. So a is going to be 200. All right, it is going to be 200. Let's not forget centimeter. Okay, so this was centimeter square, so this is going to be centimeter. Now what do we know? We know that the radius is equal to half into a. So what is the radius? The radius is half into a, so a is 200 centimeter, so the radius is going to be 100 centimeter. Now in order to find out the area of this of the shaded region, we need to know the area of the equilateral triangle, which is already given, and subtract it with this sector, right? So if we take the area of this triangle and subtract it with this 3 sector, what would we get? We would end up getting the remaining portion. And in this, according to this triangle, what is theta? Theta is going to be 60 degree. Okay, therefore you can write this. Therefore, area of the shaded region, okay, of the shaded region is equal to area of an equilateral triangle, okay, minus, there are 3 sectors, so 3 into area of sector. Okay, so we know that the area of the equilateral triangle, they have already given us 17,320.5 centimeters square, minus 3 into area of a sector is going to be pi, right? So pi, they have pi r square by theta into 360. Yes, so 17,320.5 centimeters square minus 3. They have told us to take pi as 3.14. The radius is 100, theta is 60, and this is 360. So you cancel this. 6 into 6, 3 into 2, 2 into 50. So 3.14. Okay, this is both centimeter. Clear? 3.14 into 100 would give you 314. So when you multiply that, you will be left with 15,700 centimeters square. So you subtract that 15,700, so it's going to be 600, 1000. Let's just count 732.0 and 15700. So 0 to 13 6, so it's going to be 1620.5 centimeters square. Okay, this is going to be the area of the shaded region. In the next question we shall move on. The graph is missing, but if you have your textbook, a graph should be like this. Okay, there are 3 circular discs drawn on this, and total there are actually 9. Okay, like something like this. Okay, you just refer the textbook. Clear? So this is given, and what have they given? That the radius from this is going to be 7 centimeter. So all of this is going to be 7 centimeter. Okay, that means the distance from this is going to be 7, from here is going to be 7 and 7. Now what about the diameter of the circle? The diameter of the circle is going to be 7 plus 7, so that's going to be 14, right? 7 plus 7. Okay, therefore you can write solution. Since radius is equal to 7 centimeter, the diameter of the diameter should be equal to 14 centimeter. So what should be the length of this? What should be the length of this? Very simple. Okay, this circle should go a little beyond. So this is 14 centimeter, diameter of this circle. Diameter of this circle is also 14 centimeter, and diameter of this is 14 centimeter. So what does this mean? This is 14, this is 14, and this is 14. Okay, so this is going to be 14 plus 14 plus 14. That's going to be, therefore, the length of the square. Okay, length of the square is going to be equal to 42 centimeter. Therefore, we have to find the area of this remaining portion. Okay, so in order to find out the remaining portion, we have to take the area of this square, subtract all the 9 circles in this, then we will be left with the remaining portion. Okay, see this portion, the gap that you see, a little gap that you see between this circle and the square, okay, is what we're asked to find. Therefore, area of, let's go to the next slide, area of remaining portion, okay, that is equal to area of the square. Okay, and how many circles do you see? 1 2 3 4 5 6 7 8 9. 9 circles. Subtract that with 9 circles. 9 area of a circle. Okay, so area of a square, what is the side of each of the square? It's going to be 42 centimeter, right? So for the area of a square, formula is length into length minus 9 into pi r square. The length is 42 centimeter. Yes, 42 centimeter. Okay, into 42 centimeter minus 9 into 22 by 7. The radius is given as 7 centimeter into 7 centimeter. So you cancel this, 7 and 7. 42 into 40 is 1764 centimeters square minus, okay, 154. 154 into 9 is 1386 centimeters square. Okay, so this is going to be equal to 378 centimeters square. Okay, quite a very simple, it's a very simple question. We're asked to just find the diagram is not clear. Okay, but if you have a textbook, remember what remaining circles are we talking about. Okay, so it's going to be the little gaps that you see between the square and the circle. Okay, so something like this. This is actually what the graph looks like. Okay, this is not the proper one, but so we're actually asked to find these gaps. Okay, these gaps, the remaining areas. Okay, you'll see in the diagram properly. Okay, all of these remaining areas, all this. Okay, we're asked to find that. So the way to go about it is you take the area of the square, which means the entire square, subtract it with the 9 circles, so you'll end up getting the remaining square. Now for the last question of this video, it is this. We are given a quadrant. A quadrant or a sector is more or less the same, okay? But you must understand a quadrant is actually 1/4 of the circle, okay? So this is a quadrant. Clear? This is a circle, right? So this section, the 1/4 of a circle, is actually called the quadrant. And the interesting thing about a quadrant is this angle is always going to be 90. In fact, all of this is going to be 90 degree, okay? The angle will be 90 degree. Clear? Okay, each quadrant has an angle. Okay, a quadrant will have an angle of 90 degree each. Clear? Now we're given that OD is equal to 2 centimeter and radius. Okay, so the radius is solution. Let's write this. Okay, radius is going to be equal to OB, and that is going to be equal to OA, and these are both equal to 3.5 centimeter. Okay, and we have OD, which is given as 2 centimeter. So we're first asked to find the area of the quadrant O, A, C, and B. Okay, so this actually is a sector itself. So the first thing is you go area of the quadrant. Okay, it's nothing but a sector again. Okay, so it's the sector formula, theta by 360 into pi r square. So theta is going to be 90 by 360. Nothing is given about pi, so replace that with 22 by 7. The radius is given as 3.5 centimeter, right? 3.5 centimeter into 3.5 centimeter. So you cancel this. So 9, 4, 26, 2 and 11. Okay, now what you can do after this is 11 by 2 into 7. Instead of 3.5, can I write it as 35 by 10? Okay, it's still the same. It just makes the calculation easier, so I'm taking this way. Okay, so 7 5s are 35. 5 times 2 is 10. 5 7 times is 35. 5 times 2, so we're left with 11 into 7 centimeter. So centimeter square. Okay, this should not be missed out. Okay, we're talking about area, so the unit should always be expressed in terms of centimeter square, and you're left with 2 into 2 into 2. So 11 into 7 is going to be 77 centimeter square. 2 into 2 into 2 is going to be 8, right? So 77 by 8 centimeter square. Now for the second part of the question, we are asked to find the shaded region. See this region, clear? We're asked to find this region. So if we take the area of this sector, yes, do you agree? And subtract it with this triangle, what do we end up getting? We end up getting the area of the shaded region, right? So we have this. Okay, I'll just draw it roughly. If we take the area of this sector, okay, and subtract the triangle from here, that means we subtract this part. After taking, we first take the area of the quadrant and subtract this triangle, then what are we left with? We're left with the shaded region. We know that this is given as 2 centimeter. Okay, this is OD. Okay, OD is given as 2 centimeter, and OB, okay, OB is given as 3.5 centimeter, right? Because that is the radius. OB is the radius. So if we take a circle, a triangle, this is what we have: D, O, and B. So this is 3.5 centimeter, and this is 2 centimeter. Yes or not? So therefore, area of the shaded region. If we take area of the shaded region, okay, this is equal to area of sector minus area of triangle. Okay, clear? Area of the sector is this entire part, and then we subtract it with the triangle, which is this part. Clear? So we're left with this. Area of a sector, we already know the value, so don't find it out. You just write it as 77 by 8 centimeter square. Now area of a triangle can be written as half into base into height, for the reason, simply for the reason that we already know the base. Okay, the base is going to be equal to OB, and the height of the triangle is OD. Okay, so it's going to be half into base into height. Clear? So 77 by 8 centimeter square minus half. The base is given as 3.5 centimeter, height is given as 2 centimeter. Okay, so you can just cancel this out, 2 and 2. So 77 by 8 centimeter square, 3.5, let me take this as 35 by 10 centimeter square. Okay, so this is going to be 5 7 times and 5 2 times. Alright, now let's take the LCM for that. Okay, 8 and 2, so you can just write this as, okay, we'll just end up writing it as 8. Okay, and then you write this as 77 in 7 centimeters square into 2 minus 7 into 7 centimeters square into 8, so you'll be getting this as 154 centimeters square minus 56 centimeters square by 16. Okay, so 154 minus 56 is nothing but 98 centimeters square by 16. Now you can divide this with 2. 2 times 4 is 8. 2 times 9 is 16. 2 times 8. Okay, so you'll be getting this as 49 by 8 centimeters square. Okay, if you're just confused, you just go for this. Okay, 98 times 2. So 2 times 4 is 8. So you're left with 1, 8, 2 times 9 is 18. So okay, that's how you cancel out. Okay, so the area of the remaining portion is going to be 49 by 8 centimeters square, and that is the answer that is given in the textbook. Clear? So we'll do the remaining questions in the next video.